Welcome back to our video series. In our previous videos, we demonstrated how to create a Gempy model from scratch, guiding you through the process of loading input data, setting up a structural frame, computing the model, and visualizing the results in 2D and 3D. Our last model featured 3 structural elements in 2 structural groups, forming an unconformity. Now, let's add more complexity by introducing faults. Faults in Gempy are added in the same way as rock units, using surface points, orientations, and a name. This data is stored in the same input files following the exact same format. We begin by creating a new model as before, loading input data that now includes fault information. In the 2D plot, we can clearly see where the fault data is located. As explained in video 3, we must order our elements correctly using the structural frame. Here's how we organize them. Rock 1 and Rock 2 grouped together in a single structural group as the oldest elements. Rock 3 placed in its own structural group, and the fault defined as the youngest element in another group. Looking at the structural frame now, we see the correct order. However, the bottom relation for our fault group, fault series 1, is set to erode by default. In upcoming videos we will discuss all bottom relations. To treat this group as a fault, we change its bottom relation to fault with gp.setIsFault. Below the structural frame you will notice the fault relation matrix. This matrix determines which elements the fault affects. By default, a fault will impact all older non-fault elements, which in this case includes all other structural groups. Now let's compute our model. How does Universal Co-Kriging, the algorithm behind Gempy, handle faults? Fault planes are interpolated using their own scalar field, just like other surfaces. Gempy then applies a drift function to the interpolation of affected structural groups. This function automatically calculates the offset based on available data points on both sides of the fault plane. And here is the resulting model. Additionally, we can examine the scalar field used to calculate the fault plane, as well as those for the other structural groups, showing the offsets caused by the drift function. We hope you found this tutorial on faults helpful. If so, leave a like on this video or maybe even stop by GitHub and grant Gempy a star rating. Are there any other topics you would like us to cover? Make sure to leave a comment. By subscribing, you make sure to miss no informative Gempy videos in the future.